Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In today's episode, we're comparing three of the most prominent software development methodologies in use today: Waterfall, Agile, and DevOps. Each of these approaches offers distinct advantages, challenges, and implications for security, development velocity, and operational integration. As a certified information systems security professional, it's crucial to understand the strengths and limitations of these models so you can make informed decisions, advocate for secure practices, and support software development initiatives effectively within your organization. Let's begin with the Waterfall model. The Waterfall approach is a traditional software development methodology that follows a linear, sequential structure. Each phase of the development process must be completed before moving on to the next. These phases typically include requirements gathering, system design, implementation, testing, deployment, and maintenance. The waterfall model is ideal for projects with well-defined and stable requirements. Because each phase is clearly documented and signed off before the next begins, this approach provides predictability, clear milestones, and strong traceability throughout the development lifecycle. The primary advantage of Waterfall lies in its structure. It ensures that all stakeholders agree on requirements from the outset, reduces ambiguity, and emphasizes documentation. For environments with strict compliance or regulatory requirements such as defense or aerospace, Waterfall can be a strong fit. However, Waterfall also has limitations. It can be inflexible when requirements change, slow to deliver working software, and prone to discovering major issues late in the cycle, particularly during testing. In today's rapidly evolving environments, many organizations find Waterfall too rigid for most use cases. Still, understanding the Waterfall model is essential for recognizing when a structured, disciplined approach is appropriate, particularly when the scope is fixed and the risks of midstream changes are high. Now let's explore the Agile methodology. Agile represents a significant departure from traditional models by emphasizing iterative development, collaboration, and adaptability. Agile frameworks like Scrum and Kanban support small, rapid development cycles, often referred to as sprints, where functional components are built, tested, and delivered incrementally. Agile supports flexibility, making it ideal for projects where requirements are expected to evolve. It encourages regular interaction between developers, testers, stakeholders, and users. Daily stand-up meetings, backlog grooming, sprint reviews, and retrospectives help keep development aligned with user needs and business goals. The advantages of Agile include faster time to value, better alignment with users, quicker issue identification, and more frequent integration of feedback. Agile allows teams to make adjustments quickly, which improves responsiveness and reduces the risk of building software that doesn't meet actual needs. However, Agile also has challenges. It requires strong team communication, disciplined backlog management, and the active participation of stakeholders. Without proper coordination, Agile teams can suffer from scope creep, inconsistent quality, or misalignment with broader enterprise goals. Still, when implemented effectively, Agile allows organizations to respond rapidly to change, continuously improve, and deliver value quickly. And now let's introduce the DevOps approach. DevOps is a philosophy and set of practices that integrates software development, referred to as Dev, with information technology operations, known as Ops. The goal of DevOps is to deliver software faster, more reliably, and more securely through automation, collaboration, and continuous improvement. DevOps emphasizes concepts like continuous integration and continuous deployment, often abbreviated as CI/CD. Developers commit code frequently, automated tests are run immediately, and approved builds are deployed rapidly, sometimes multiple times per day. One of DevOps' most powerful characteristics is its reliance on automation. Infrastructure is provisioned as code, deployments are automated, and monitoring is built into every stage. This not only improves speed but reduces the chances of human error and increases consistency. Security in the DevOps world has evolved into a specialized discipline known as DevSecOps. This practice integrates security directly into the DevOps pipeline, embedding security testing, code scanning, and compliance checks into automated workflows. DevOps offers numerous advantages, including rapid development, scalable operations, resilient infrastructure, and improved collaboration between teams. But it also requires a significant cultural shift, investment in tooling, and a high degree of process maturity. Understanding DevOps is key for aligning security with modern development practices and ensuring that fast software delivery doesn't compromise integrity or compliance. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyberauthor.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now compare these three approaches side by side. The waterfall model is structured, predictable, and documentation-heavy. It excels in environments where requirements are stable and regulatory oversight is strict. However, it lacks flexibility and can delay the discovery of major issues until late in the process. Agile, on the other hand, offers flexibility and adaptability. It supports ongoing stakeholder engagement, encourages feedback, and enables faster delivery of working software. Agile is well suited for dynamic projects with shifting requirements, but it requires consistent communication and strong project discipline. DevOps prioritizes automation, integration, and operational alignment. It accelerates delivery, improves system reliability, and supports frequent releases. DevOps can scale quickly and handle modern development workloads, but requires a commitment to cultural change, tooling, and shared ownership. Choosing the right development model depends on multiple factors: organizational culture, project scope, timeline constraints, risk tolerance, and compliance requirements. In some cases, a hybrid approach may be best, blending elements of Agile and DevOps, or using Waterfall for regulated components and Agile for user-facing modules. Now let's consider the security implications across each approach. Waterfall offers clear security checkpoints. Since each phase is distinct, organizations can insert security reviews at logical milestones, such as during design, implementation, and pre-deployment. Documentation is thorough, which aids compliance, but vulnerabilities may go undetected until late in the cycle. Agile encourages continuous security involvement. With smaller, frequent releases, security teams must integrate into sprint cycles, conduct ongoing reviews, and participate in planning. This model supports incremental vulnerability management, but can be challenging if security is not included from the beginning. DevOps demands embedded security. DevSecOps integrates security tools into the automated pipeline, ensuring that code is scanned, tested, and validated before deployment. Continuous monitoring supports real-time risk detection and mitigation. Security in DevOps is not an afterthought, it's part of every phase, driven by automation and built-in controls. Each approach has its own strengths, but the key to success is aligning security strategy with development model characteristics. When security is tailored to the workflow, it becomes part of the process, not a barrier to delivery. Let's wrap up with continuous improvement in development methodologies. No matter which model your organization uses, regular refinement is essential. Evolving threats, changing technologies, and new business priorities require flexible, adaptive processes. Use incident analyses to identify root causes, missed opportunities, and breakdowns in communication. Review software performance metrics like defect rates, release frequency, and time to recover from failure to evaluate development health. Solicit stakeholder feedback to understand user satisfaction, internal coordination, and delivery effectiveness. Build this insight into retrospectives, design reviews, and sprint planning sessions. Encourage cross-functional collaboration. Involve legal, compliance, security, operations, and business teams in development planning. This ensures alignment and helps reduce risks and surprises later in the life cycle. Maintain regular training. Developers, project managers, and security professionals all need updated skills and awareness to manage tools, code securely, and collaborate effectively. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of Waterfall, Agile, and DevOps approaches and will consistently support your journey toward CISSP certification success.